Okay, the banner, so it should be good. Good morning. Thank you for joining me today in the October CEDEN user group meeting. This is Jarma Bennett with the State Water Resources Control Board. We'll go ahead and get started. I wanted to first announce or let people know, if they didn't already know, that there's a California trash data dive or datathon coming up next week. There are 3 tracks involved, and if you go to that link provided in the agenda, you can read about what those 3 tracks are and participate if you're interested. We've been participating in this event. We, meaning the water boards, have been participating in this event for several years now, and so we're continuing that this year, and hopefully it'll be interesting. Let me just, okay, I think we're still good. And so then we'll move on to our main item this morning, the passive sampler related template entry. We talked about this last month, and we started going through a document, which we'll get to in a minute. And in the interim time between these 2 meetings, I've gotten a lot of, or some feedback during that time, suggestions. One of those was from Marco Segala and Dr. Cajun James and Will Hagan. I attached their informational document to the agenda email, and it was covering information on the units. So we'll look at that. And also a suggestion from Will Hagan to use the term sorbent. In the first draft of the guidance, I had used disc, and we talked about last time that not all devices use discs. And so that wasn't a universal enough term. And so his suggestion was sorbent. I tend to use, had been using that as like sorbent material, but I've tried to update the guidance to try that term out so that it's just sorbent as a noun. And so we'll see that. And so I'll bring our document up. So I've used it as continued to just add on to what we had been working off of last time. So you see here, I took out material, so it's just sorbent. Sorbent again. We talked a lot about whether to try to accept only analysis of that sorbent, or to accept both the calculated, or whether it's either the analysis of the sorbent or the calculated outcome for the concentration of analyte per volume of sample water, or potentially both, knowing that not everybody knows the ins and outs, including myself, of getting from one to the other, while others are, have a lot of practice in that, have a higher confidence in that number, and the devices and sorbents that they're using have the applicable coefficients available to use in those calculations. So I added a little blurb about the priority is to enter the results of the sorbent analysis, and using the metadata specified, that the entry that we're describing this guidance, but if you're confident in that calculated value, you can add that as well, along with the coefficients, I guess, that are used, or other variables used to derive that calculated value as well. So it is now going for both ways. Any questions or comments so far about where we talked about and where we are now? Okay, then we'll move on. It was pointed out last time that I had originally suggested sample comments, but it was more appropriate for lab collection comments to provide the number of days the passive sampler was deployed. So that's changed to lab collection comments. Sample type code. We talked some about that, or a lot about that last time, that integrated would be a more appropriate term potentially, or it seemed like a more appropriate term, but that our current definition of integrated didn't quite fit what passive samplers were doing, so that we should update that value. And I haven't proposed that yet, that updated definition, but we're going down that path of using integrated for environmental sample. Then it was pointed out to me that there are QC samples involved, and so that wouldn't be appropriate for the QC samples, and that field spike for the spike sorbents could be used. That's already an existing value, and there may be others, but that one was specifically mentioned, so I added it to this guidance. Along the same lines, I had originally said that proposed that the replicate just be one, but have subsequently learned that there are often places for multiple sorbents, I guess, exposed to the sample medium at the same time within the same housing, and therefore those would actually be acting as replicates. And so then I just said each with a sequential replicate number starting with 1. Hopefully that's clear. The collection device name, I've added to, it was pretty jam-packed full of information, but it was suggested, I think, by Marco, that we also include sorbent size. So at times, I think during our last discussion, it could have been added into the units or somewhere else, but that the device name could have the size, and so we've given and added that size on. It's a little hard to specify exactly how it should be entered because of the various devices. Some have discs, some have cartridges, some have other things. So hopefully just by saying to add the size and giving an example of that, will at least at the beginning have enough. We have a suggestion here, adding pore size to the membrane type if possible. Thank you, Tiffany. If you've had a chance to look at what we have as our kind of examples of collection device descriptions, which are a little bit longer. Was there a way that, do you have a more specific suggestion of how we could fit that in as well?
Yeah, I was looking, like, you have things where you have diffusion limiting membrane, like polyether sulfone, like PES membrane, but those come in, like, I don't know, probably like 15 to 20 different pore sizes. And the sampling rate number, that RS number, is dependent on the pore size in the membrane. And so just identifying that it's a PES membrane isn't necessarily enough. It's sort of the same thing as the sorbent material. You need sorbent material and size, and you need membrane and pore size if the membrane actually has pores that it's diffusing through, if it's a diffusion limiting membrane.
Okay.
Because, like, we've done a couple of experiments with like 8 micron pore size PES membranes and 0.1 micron pore size membranes, and so we would list those differently. Does that help?
Yeah. So the gist of it is that the sampling rate is dependent on the pore size, or those are linked, and so it's important to have that. So if we have polyether sulfone, would you
PES,
like
yeah.
do a, what was that?
Like PS, like 0.1 micron or something like that. And that would be the pore size. Because I like when you're trying to apply those sampling rate numbers, those are often given with, I mean, those are a diffusion based number. So those are often given, those change based on the pore size of your membrane. And so if you're trying to look up applicable numbers from the literature, that's like something that you would need to know if you were trying to convert into time weighted average concentration.
Okay, so like, did you say 0.1
Like
was,
0.1 micron is the usual that people use for PES membrane. Yeah.
so let's see, first we're in our,
Yeah.
and then we'll probably do that P. So yeah, I don't think we can have multiple devices with the same name. So is that, if everything else is the same except the pore size, well, this will need to be unique as well. So we'll say the same thing
Right.
here.
Yeah.
Wait. Okay, that's our, sorry, wrong place. And it should go right after that. So let me see. So this would be like 0.1, and this would be applicable. So this, got it right. So is there only a pore size if there's a DLM?
I think yes. I mean, I think, I only really have experience with the diffusion limited membranes, but I know that there are some other types of membranes, but I don't know if those come in, different pore sizes or how those are really described.
Oh, okay.
So I think there might be a situation in which you wouldn't have a pore size, but I'm not actually sure.
Okay. Well, I think if applicable is safe.
Yeah, I think that's great.
Okay, thank you. Uh, okay, great. And then we didn't have, I think we probably um, got to hear last time matrix We're suggesting to use extract sample water when which we have in our list already, or extract pour water that currently says we currently have a value that's extract sediment, but thought that that wasn't like extract pour water better described what was actually being sampled when you place it in sediment. So that's what we're suggesting be used. But yeah, so the current value would be undated, and we'd add this new extract pour water instead. Method used to analyze the filter extract. Fraction name, dissolved. This is our big decision about units. So I'll pull over our information that Marco and team provided. Marco, did you want to, or Will, or others, did you want to talk about this at all, or to just show it?
I mean, we can talk about it in like at a higher level, or if people were able to read it and have specific questions. You know, the main idea behind it is that originally we had brought up the idea about reporting it as like nanograms per sorbent, but then as we were looking into it, we thought, well, what about the size of the disc? You know, that's important too. But then as we looked into that and talked with a manufacturer, they said, well, the size of the disc gives you kind of a general idea about it, but really it's the amount of sorbent that's what's inside that disc that's really important. And then that kind of got us into surface area, and then volumes, and then, you know, mass of sorbent. So it's just, you know, different options, and we just wanted to kind of lay out all of those options and kind of leave it up for discussion on what people think would be the best way to store the data, if it's better to standardize, or if all options have to be available. We're not quite sure.
Yeah. Okay, thank you. Yeah, I was wondering whether, you know, the idea of trying to have a unit that made those measurements comparable, and I wasn't sure if that was would really be done. Would it be meaningful to compare if we use the massive analyte per massive sorbent, which seemed like it would bring us to better comparability. Would that be something that we would make that comparison? Okay. DPR and CDFA currently reports mass analyte per massive sorbent, so that exactly is laid there at the bottom. And then total deployed mass of sorbent and the surface area exposure. Tiffany, can you tell us how are those all separate? Do you have like separate columns in your database or input format that allow you to record all that, or is it recorded as like in the same as different rows, but looks of the same sampling event?
Yeah, we would do it as separate columns for each sample. So John from CDFA, who does our method development, I think he's actually here. So the data that he reports back to me is mass of analyte per mass of sorbent. And he actually weighs in the lab after doing vacuum drying on the solid phase extraction exactly how much mass of sorbent he extracted for every single sample. And so that's really the only way to get the mass of the analyte. And you can assume, you know, some people assume, okay, well, I deployed 200 grams or 200 milligrams of sorbent, and they just sort of run with that number. Like, I have John weigh it just because it's sort of easy, and then we get like an exact number. So it's a little bit different every single time. And then sort of the last component of that picture is the surface area exposure of whatever that sorbent was deployed in. Because sometimes we deploy 100 grams or 100 milligrams, sometimes we deploy 500 milligrams in the same type of sampler. And so we have all these sort of different variables that happen on my end in the field. But from the lab's perspective, like the only thing that John can really report to me is mass of analyte. Oh, I think, sorry guys, I think the earthquake thing is just going off.
Everybody be safe.
Yes. So the only thing that John knows at the lab is the mass of the analyte that he's detecting and the mass of the sorbent that he's analyzed. And so those are really the only numbers he can directly give me from the lab. And I have to post-process everything with all the numbers from the field. And so basically these three numbers, like the mass of analyte over mass of sorbent, which is the concentration, right, in the passive sampler, the total deployed mass of sorbent, and the surface area exposure are the three numbers that you sort of need to get yourself to a time-weighted average concentration. And so we sort of keep those separate because John can really only report two of those to me. And then the last one is sort of on me to figure out. But I think this is sort of addressed in these possible unit options. Like, you guys have clearly sort of thought through this, but it's one of those, like, really the lab can only return nanograms per gram. Like, that's the unit that they get off the analysis.
Okay, so that's a good
And John,
point.
you can correct me if you're here if I'm wrong about any of that.
Yeah, that's correct.
Okay. Yeah. Interesting.
Tiffany, hi, this is Marco. I was wondering if you can, hi. So you said like you calculate the mass and the surface area. Are you getting like the surface area from the vendor, or are you just doing that on your own?
We are currently fabricating all of these in-house. So we have a couple different types that we're sort of experimenting with deploying. They're relatively easy to make on your own in the lab. We had one that we sort of designed that went down the sounding port we mostly do this in groundwater. So we had one that we designed that went down a sounding port on a well cap, so that we had to custom design that because it's only about a centimeter across to fit something down that hole. So that was a huge production. But then we have sort of another device that sort of, it's kind of like a flow through cell that we stick outside the well. And then with that, we have a whole bunch of options because we have a whole lot more space. But yeah, we ended up, not buying anything just because we couldn't find anything to meet our needs, and they're relatively easy to make. And I have a feeling that sort of moving forward, you'll see a lot of people making these on their own just because it's way more cost effective and they're not really hard to put together. Basically a couple of washers and you cut the membrane and throw some sorbent in there.
Well, where are you buying the sorbent from? Is it like a liquid or?
So the sorbent is it's a solid phase extraction medium. So we use Oasis HLB, which is the most, I think, commonly deployed sorbent in a passive sampling device. And that can be purchased direct from the manufacturer in bulk. And it just comes in a big bottle. The lab, when they do solid phase extraction, the cartridges that they have are actually pre-packed with that sorbent. So like when you submit a traditional water sample to the lab and they do solid phase extraction, it's usually over that type of sorbent. So we buy that direct from the lab or direct from the manufacturer. And I think there's like a couple vendors who buy it from them, at least through the state. And then the membrane, like the PES membrane, we also buy that. We buy a huge roll of it and just cut pieces off. And then, sort of the other equipment that makes it into a sandwich, you can get, like, we buy really big washers from McMaster Cars, sort of how we're currently doing it. We've 3D printed some plastic housings to hold the membranes in the sorbent. And so there's kind of a lot of options.
Oh, that sounds neat.
Yeah, thank you. It's interesting, like with your
Yeah, sure.
thoughts about, people building their own, because that just makes it even more important to be able to document, the different pieces of information.
Right. And that's sort of how I think about it, because it's like, at the most basic scale, they all sort of have the same parts. You just need to know how it was put together in order to get that information standardized into the database. So for us, that's really just like these 3 parameters. It sort of, it doesn't really matter what you do outside of that. I mean, there's like deployment time and stuff like that you guys have already accounted for. But in terms of like the actual concentration and sort of what's being reported back from the lab, it's really that mass of analyte per mass of sorbent number. That's the concentration number that John gets off the machine. So
Okay. So yeah, and since the lab can provide that, that sounds maybe not as hard to obtain as I was thinking. So maybe
I'm not sure how like other agencies, like where they're currently getting these analyzed, or sort of, if there's private labs that are doing this and how they're reporting the data back. I know someone maybe from USGS is here. I think USGS was doing it in a private lab or in-house. I talked to Dave Alvarez about it a bit at USGS, but they report that this as well, this nanograms per gram total deployment mass and surface area exposure.
how does the surface area exposure help you calculate? Does that go into the RS value?
Yes. So the RS value is dependent on the total exposed surface area. Yeah. And I had a document earlier with this equation somewhere.
So you're calculating your own RSs?
We have an upcoming study that we're doing to get RS values for our specific passive sampling devices. So once we sort of settle in on a design that we sort of want to go forward with, the RS value is dependent on your device design. It's dependent on that membrane. It's dependent on your surface area exposure. It's sometimes dependent on temperature. There's sort of a lot of underlying variables that go into calculating those RS values. And you can pull, a whole handful of them from the literature for any one analyte. Just sort of why I agree with you guys' assumption that you really shouldn't be reporting like these time-weighted average calculations, because you have to know that the RS value was appropriately chosen in order to calculate that number. But yeah, to get the actual concentration, like your time-weighted average concentration in the water, you need massive sorbent. You need the concentration on the sorbent, which is that mass analyte over mass sorbent, which is nanograms per gram. You need your RS value, which is the sampling rate, and you need the total time it was deployed. And since we're primarily looking at pesticides and pesticide degradates, and so there's not a lot of available RS values for those. So we're sort of making those in-house, but that's a whole different project.
Do you know if RS, can you use a RS value for groundwater the same as you would use, like the same number, the same value for
theoretically, yes, as long as realistically, the RS value is pretty much just dependent on it's like a physical diffusion rate basically across the membrane is really sort of what that number is getting at. It is dependent on turbulence across the membrane as well. So like having, higher flow rate across the membrane does affect that number. So you could, like, the difference between something in groundwater versus surface water, like groundwater can move very slowly versus surface water, but it's not, that's sort of one of those considerations as well, as you have to know sort of the environment that the RS value was determined in, which are often, like sometimes in the literature, those RS values are determined in the lab, but then these are deployed in the field and you have water going by like, 200 cubic feet a second. Like, what does that really mean in terms of your RS value? It could be like a totally inappropriate value to be applying.
Yeah, and everything that we've seen, it seems like the sampling rates, they're really affected by temperature, flow, pH. So like a stream environment, sample water environment seems more variable, across the whole state and would be less likely to be applicable. Whereas like groundwater might be a little bit more stable. So it seems like that would be an easier way to argue it.
Yeah, it's definitely a little bit easier in groundwater than it is in surface water. But the two other big factors for that are the type of sorbent and the membrane that you're using. So it's like, it's all of those things combined make up this like sort of RS value. That's, to me, it's sort of just like this fictitious number that it helps us get back to what we think that the time weighted average concentration is. But I mean, you have to have it under very controlled conditions in order to figure out exactly what that number is. Like technically you should be determining that number in the exact same environment with all the exact same materials that you are taking your samples from, which pretty much is never going to happen because you have to do it with like spiked analytes, right? So you're definitely taking it with a huge grain of salt when you apply that RS number to get a concentration out of it, like a water concentration.
So how do you apply your results from passive sampler monitoring?
We primarily use the results, or at least our plan is to use the results to really look for presence absence, I think is one of the biggest things. So we're looking for presence absence of compounds that could potentially be at concentrations that are too low to detect in a regular grab sample, right? Because the passive sampler amplifies those concentrations. And, in some cases, we're using its presence absence of things that might not necessarily be too low, but when you have a lot more of it, you're a lot more confident that that's what you're detecting. So we kind of use those in that aspect, and we use those in combination with non-target analysis because the detection limits for non-target analysis can be a little bit higher, and you want to have a lot of what you're looking for in order to be certain that that's what you're finding. And so we use that to hopefully inform developing new methods, like new targeted methods to specifically look for chemicals that we're finding. So that's sort of what we're using them for, yeah.
That's very helpful. Thank you. So bringing it back to the units issue, it sounds like the mass of analyte per mass of sorbent is one of the most useful metrics and is obtainable by the lab. So I was still kind of voting for the mass per sorbent, but after this discussion, I think I've changed to mass of analyte per mass of sorbent. What do everybody else think?
It seems like it's the most appropriate and is like the basis of what a lab would report. It's kind of like with I always kind of go back to thinking about chlorophyll data, where a lab either reports micrograms per liter or milligrams per liter that chlorophyll is in, but for the bioassessment program for calculating benthic chlorophyll, we have to account for the areas sampled and the volumes filtered and for the composite volume. And so it's always kind of tricky for the lab because then the field crew has to provide that associated information in order to do a calculation. And so some labs just say, well, let me just give you what I read off the machine and then you do the calculation. And so it's kind of like we're in the same scenario here. Do we just have the lab report it as nanograms per gram and then store this other information so that end users, if they want to, could do their own calculation to try to extrapolate into something else.
Yeah, that makes the most sense to me. As long as we have enough places for this, all the those other pieces of information. Okay, well, we'll leave that for.
Yeah, I think the only thing is if you choose that as your unit, like you have to also be reporting the total mass that you deployed. Like those numbers have to be reported in tandem. Otherwise, you can't get out of that. You can't ever make the calculation out to a different number. And I pasted a little picture of that formula in the chat.
Cool.
So the CS number in this formula, that's the mass analyte per mass sorbent. So that would be that nanograms per gram. And then MS is the mass of the sorbent. So that would be something like 200 milligrams. And then you have the RS value, which is your sampling rate. You have T, which is the time it was deployed. And that's how you end up calculating the equivalent time-weighted average water concentration. Yeah.
So Tiffany, when you were saying that John reports to you as massive analyte per massive sorbent, does that mean that you're giving him the amount of sorbent that was included in that so that he could report it as nanograms per gram? Okay.
Yeah, so he extracts across all of the sorbent. So he basically takes the sorbent out of the sampler and packs it into a cartridge and then does solid phase extraction over that sorbent. Like that's how that's done at the lab. And so he can either believe me when I say I gave you 200 milligrams of sorbent, like I packed 200 milligrams in the sampler, or he can vacuum dry it and weigh it when he's done. And then he'll say, oh no, you really gave me, 198 milligrams or something, which is a slightly more accurate number, but your difference is not going to be that large. But you have to know, so yeah, so he reports that CS number and he also weighs it for me, which is nice. Then I don't have to be super exact when I'm filling them. But that massive sorbent could either be something I come up with or he comes up with. And then the CS is that nanograms per gram number.
So then it seems like in reality, though, that the lab, the easiest for them would be just to report the mass of the analyte. And then, then they don't have to worry about calculating it or weighing sorbents or any of that
Well,
stuff.
I think, John, correct me if I'm wrong, but the way that it is reported, I don't think John's doing a calculation. I think the number he ends up getting is in nanograms per gram. Or are you dividing it?
Yeah, I do measure the actual mass of the sorbent, and I can report that, or basically the information that I have is I have the amount of each chemical that I detect, and I have the mass
in nanograms, right?
of the sorbent. Right, and so I can report. I can format it however you want or anyone wants, but that's the information I have.
Right.
And it's
is
really
that per
easy.
is that per the analytical method protocols for weighing out the sorbent? Because I'm just trying to think of like a commercial lab, if they're following a protocol, if it doesn't require or recommend that they weigh the sorbent, are they just going to provide the mass of the analyte?
That's a good point. I would think, I guess, in that case, they would provide mass of the analyte. I mean, John, is that what you would do if you didn't know how much sorbent was there?
Yeah, I would essentially report the mass of the analyte per sampler.
Okay,
and then
yeah.
you would decide what to do with that, whether you assume 200 milligrams or whatever. So what I do on my end is I detect the mass per sampler, and then I can just divide that by the mass that I measure from the sample.
Mm.
And are you following a standard protocol?
I've developed this protocol. We have not done a lot of passive samplers. We've done a few, so you could say that it's still under development. The analytical technique works, but I'll probably have to analyze several more passive samplers before I've done it enough to say, here's a tried and true method for the sake of reporting the mass, reporting mass of analyte per mass of sorbent. I just haven't done that very many times yet, so I'm not 100% sure, that I have the exact method for that. But the answer is, so we did create a method that we follow. The only challenge from the lab point of view, the only challenge is you have to remember after you do all the extraction that you've got to dry it down, make sure that it's dried down completely, and you have to weigh it. You have to weigh the cartridges before you put the sorbent in them. You have to weigh them with the fritz empty, and then at the end you have to make sure it's completely dried down and weigh it again. And so that's just an extra step that would be part of a contract with a lab if they're willing to do that.
Yeah, right. Thanks.
So then we'd need, I think, if I'm following, a spot for the mass of the deployed sorbent.
Yeah, I guess it would be mass of analyte would be one variable, and then the next variable would be mass of sorbent.
And we're working within our existing format, so we don't have a lot of extra columns to
Yeah.
put numbers into. But let's see, let me at least record. Not guidance, this is just a note. Okay, so I think we're still a little undecided on this one because of the need for both measurements, but it sounds like we need two, regardless of whether they're together, and the nanograms per gram, and then just the mass of the sorbent, or the mass of the sorbent and the mass of the analyte. We still, which no matter which way we go, we still need two spots. So I'll still highlight that and can think about where to put that other measurement. But we'll move on. Maybe we can make it through. Then the lab replicate enter according to lab analysis of extract. Prep preservation, I had said that, or the proposed was field filtered. Marco pointed out that sometimes there's preconditioning of the sorbent, and that could potentially go in this field, the prep preservation. But I don't know what that looks like, if what our options would be, so we can put them in our valid value list for prep preservation. But it seemed to make sense there. And then,
Sharma,
uh-huh.
for that I'm just wondering, is there, like when somebody spikes something before it's deployed, is that, or somebody does a field spike, does that count as a preservation? Does it have its own name currently? I'm just wondering, I don't know.
I'm not, yeah, I don't, anybody have a thought on that? Let me just at least mark down the comment.
I mean, I guess the sample type notes that it's a field spike, but I guess it's not actually considered a preparation of that sample.
Yeah, I mean, thinking about other types of, or, you know, just regular grab samples, I don't know if that's too different of a procedure, but I don't think we don't use the prep preservation for those.
Yeah, I guess in this case, preconditioning is a little bit different than spiking, where spiking, you're adding a known concentration. The preconditioning actually makes the sorbent active. In some cases, they need a preconditioning step, like methanol or something, a certain chemical that will help activate it. And so if somebody doesn't precondition it, then in theory, it's not going to hold on to any, or I guess be less likely to hold on to any of the analyte.
Yeah, so I think that, yeah, that's part of just the regular sampling process, whereas the spiked version is just as part of the QC process. So, and Stacy also didn't think it would go in there. So I think we'll assume that it doesn't, or not assume, but we'll propose that it doesn't, and we can just, for now, just leave it as preconditioning was done, include that as well. If we don't have any examples of how that would be recorded, I think we can still proceed and, you know, when we're finished with everything else, making this a final document without having examples, and then deal with that as those come up. And then going along with the prep preservation name, the prep preservation date, it's suggested to be end date and time of deployment, and then the method or digest extract method would be method for extracting analyte from filter, and the date that that was done in the lab. And then, okay, cool. There's some chat for somebody to reach out to, so that would be very helpful. I can do that. And more about the mass or the unit, so I can look at that more closely. Great. Okay, so I think at this point we still just have an unresolved issue about the units and more, and the related issue. I'm not sure if it's quite about the units or just not having enough spots for the both measurements, the mass of the sorbent and the mass of the analyte, because they interplay with each other. So we'll continue to think about that. So we are not final yet, but otherwise, do people have any comments? I will reach out to David as was suggested, and still accept other comments, but so I think I'll try to clean this up and send it out, let people mull it over, and then we can still revisit it. We will revisit it next month as well, just to see if everybody's still feeling good about how we've laid this out. Were there any other comments or concerns at this point? Okay, well, if you think of any, please do email me. And thank you, Tiffany and John. Hopefully we didn't put you guys on the spot too much, but I do appreciate your experience in this area.
Yeah, thanks for having us. It's helpful to see how other people are also using the data because we're sort of just like, weed whacking and, going off into the unknown. So it's helpful to see like how other people would interpret the data and need to be using it and, how to make these systems and databases compatible with each other. So it's really useful for me to see this stuff.
Well, good. I'm glad we're not just taking information from you. Hopefully we can provide something. And yeah, I'll ask Nick to post the recording and send that link out when it's available. Okay, well, we'll wrap this up for today. Again, thank you guys for participating and hope you have a great day.
Thank you, Jerma.
Bye.
Thanks, Jeremy.
Thank you.
Take care.
You too.